Thank you, and welcome everyone again. So today, my name is Ivan. I'm from Boozt. I'm team lead for the team who is building our customer service and order management app. Yes, and yeah, probably you know the Boozt. I hope. I think we are kind of well known in the Nordic countries, and maybe well known as a fashion company. But now we are moving to more to the department store. So, and we decrease our part of the fashion part to open to more new categories. There is a kids, sports, etc. And yes, we're quite big, so we have 3 million plus active customers. We have a good score in the Trustpilot because we're focusing on the customer service and provide trying to provide the good service for our customers. We have a 7 plus million orders, and we're working on the 15 markets in the European Union. And we have about 1,200 employees. Yep. I'm from the platform, and today's speakers from the platform. And here is our logo and motto: "Power to the people." So we, it's our motto. We basically give the rest of the employees the power to doing their stuff, and we are kind of the more tech company, not like a fashion company or something like that. So we have a lot of cool. We are doing a lot of cool stuff, and yeah, it's yeah, it's good. And I think the better to introduce our platform team. Introduction about our platform team will be done by our SEO Jasper. And here is the short video about the platform.
The Boozt culture is fantastic. We have the values that we really believe in and have been living since day one. From platform point of view, we are even more lucky from the sense that we started the team from scratch. When I came in, there were nobody, so we actually could shape our own culture as we grew from nothing. We are born digital. We've been that since day one, and we are used to thinking in processes and automation, optimization and scalability, and being what we call an exponential company. So being able to be efficient with the people we have and the resources we have. We have always been, and we are still, extremely dynamic in our organization. Some actually called it an organism, not an organization. I think that's cool. So we are dynamic and we collaborate, but we are still fairly small in the way of thinking. And that's very much due to the startup mindset that we want to keep. An ideal platformer is dynamic, is okay with handling several things on the same time, is open and honest, both in giving feedback but also in receiving feedback, and is willing to try something new, because we are going new paths.
Yes. So about the dynamic part. So we, you probably knows. We are working with IT stuff. So everything constantly changing, new technologies all the time. So and we need to be dynamic and adapt to the situation, not only in a IT area but in the market as well. So and we try to be more flexible and work like a startup. We're not startup anymore, but we want to use the same ways as the startup doings because of its yeah, it's more efficient way. When you cut the corners, skip some, I don't know, when you have the multiple layers in a structure in the company, then it creates some obstacles to build some awesome things. Yeah, here is the picture from our platform conference. It's an annual event, and we constantly working on improving ourselves. We're getting new knowledges, sharing new knowledges, and Yes, and now it's a little bit more fun part. I have some giveaways for you, and it will be the 5 T-shirts like I have, and it's actually our one of our brand. It's Enkel Studio from the Denmark, and pretty good quality. Yeah, but you need to guess or answer to my question to win it. And the first one, how many do you think developers working in the Boozt? Just try to maybe guess, and don't use the hint from the slide. So just guess some numbers. I don't know. 100. Who more or less? 200. Somebody else? Okay, 200. You're closest. So it's not 200, but 180. Find me after the whole event. I will give you your present. Okay, the next one. Yeah, I need to check because of its. Yeah, I will check. So you don't need to, if you know the answer. Okay, how many offices do we have? One here in Malmo. So we have it's kind of our the biggest one. But try to guess how many offices. No, okay, 5. Probably you know. Okay, we have 5 offices in Malmo, Aarhus, Copenhagen, Poznan, and Vilnius. So Sweden, Denmark, Poland, and Lithuania. Okay, find me after talk. Okay, and as we kind of the tech company, we're of course building a lot of systems by our own. So not just by, and how many tailor-made systems do we have in our company? Okay, who less or more? 10, okay. 13, yeah? 50, okay. No. 45? Okay, you're closest. 40. Yeah. Yes. Okay. The next one, maybe you know we have our warehouse in Engelholm, and it's actually quite automated. We have the auto store there system, and we kind of always on the top, inside the top of the biggest or top of the biggest in the world. So. Which place do we take? The 5th, 2nd, 3rd? What do you mean? Yeah. 5th. Okay. Who more? No. Who? Yes. Yeah. Do you have the biggest auto store installation in the world? So now it's two actually buildings, a lot of robots everywhere. So it's quite interesting. I hope maybe somebody will give a talk here about our auto store as well. So it's quite interesting. We have done it before. Maybe you can find it on YouTube on the FooCafe. Yes, the last one. Too much security on my phone. Yeah. How do you think we have our LinkedIn account, and we post our blog post in the Medium? So how we call our account? What's name we choose? So there is a hint on the slide. Booztech. Yes, Booztech. Yeah, and you can use this QR code and scan it and go to our page, and you can subscribe to our LinkedIn account and get more information about our company, because we're constantly posting there some interesting stuff what's happening inside the company and inside the platform. And by Boozt tech, you can find and filter out all posts related to the platform. Yeah. I think that's it from my side. And please give the warm welcome to my colleagues, Marco and Edvardas, and they will run their microservices versus Monolith system.
Thank you, Ivan, for such a great introduction. I'm sure I know more about Boozt than I did before, so thank you very much. So today we're going to talk about microservices versus Monolith, and let's start from who we are. First of all, my name is Edvardas Kazlauskas. I'm a director of engineering. I started working at Boozt in 2017, started as software developer. So already working there for quite a while, and I also had experience with both monoliths, microservices, designing, implementing. So hopefully what I say will have some worth to you, and it will be interesting. I'm happily married. I have also 2 pets, a cat and a dog. Here you can see my dog, Meta. While she was still young, crazy, and small. Now she is big and still crazy. I like working out. I like also hiking. And the third hobby is eating, but you can probably also tell that by me looking at me. So now let's give a stage to Marco.
Yeah, I am Marco Rosello. I'm Spanish. I joined Boozt a little bit earlier than Edvardas, also a software developer. And I do now kind of everything, architecting, talking to business, developing when I have a little bit of spare time. Yeah, I'm from Spain. That's important. My first joke is related to that, so yeah. Husband and father with a little kid, so don't get to sleep too much. Yeah, I like sports, triathlon, and as you can tell, also share some hobbies with Edvardas.
Cool. Thank you, Marco. So before we dive in, let's talk a little bit about the theory of microservices, just so we are on the same page when we talk about microservices. What do we mean? So first of all, when you hear word microservice, you can already probably tell a couple of things. So first thing is that micro defines the size. It's something that is not too big, but also not too small, not on a nanoscale. And another thing is that it has a clear function. So it's not only data, but it also has to do something with in terms of functionality. And on the right side, you can see kind of representation what microservice is. It clearly encapsulates a couple of things. So first of all, it encapsulates some sort of functionality, core value, and then the data as well. And in this talk, when we talk about microservice, we are talking about stateful microservices. And that means that microservice operates on some sort of data. It stores some data internally, and this internal state can also change the output of the service, versus stateless microservices that are usually more well known as lambda functions or some sort of functions. And as well, the third very important part is that microservice has an interface. So all the data exchange and functionality exchange happens through this interface and no other way. So clear encapsulation, interface, data, and function. And one of the important things to get microservices right is microservice granularity. By granularity, I mean if it's what sort of size it is. Is it too big or too small? And it is very tightly coupled, or getting microservices correctly is very tightly coupled to how your organization is structured and also how your data is structured. And here we come to a second point. Probably you heard Conway's law. And what does it mean? That the design that your team produces, it usually resembles a team structure or communication patterns across organization. And if we simplify it and make it more understandable and adopted to microservices, we can say that when microservices are done right, they work in harmony with organizations' communication patterns. So in my book, microservices is not so much as a technology or for technology, it's for solving organizational things and helping organization to align and to evolve. And here we come to one of the biggest advantages for microservices. Here you can see a small picture of two teams, and they are arguing with each other. And so when you have a single thing and you put two or more teams on it, you say work on this thing, what is the output usually? You have a lot of unhappy people and no work done. Why is that? Because teams want to be autonomous, they want to run independently, they want to own the stuff that they build, and they also want to be in control of the data. And microservices, they actually do that. They enforce natural boundaries by introducing network around these services, these systems that you are designing, and thus promote ownership and autonomy for both code and the data. And then if it's true, if the teams, like sometimes I have trouble with making people within the team communicate, and imagine if I need to make two teams communicate and align, it's even more trouble. So if we say that the communication across teams is some sort of a bottleneck, it can be tricky to do, then promoting clear interfaces and ownership, it reduces this bottleneck and makes organization more agile. And there are, of course, other benefits of microservices. This is the main one in my book, that it promotes ownership and autonomy. So teams can run independently. And of course, if you are running independently, you have other practical benefits. So as a team, you have to, and you can choose your technology stack, and it doesn't necessarily need to align with whatever other teams are working with. You are not blocked by other team deployments. You can deploy your product independently, and then you are in control of the data. I own the data, and I decide how my data is going to be shared with the rest. Yes, but I know that Marco is dying to give some counter comments to this, so I will give a stage to him.
Yeah, microservices is a little bit old-fashioned. Elon Musk is shutting 80% of them already. So, yeah, let's go to the issues we have. Yeah, so when you have different microservices, you have a little interface, but probably you will use network, some sort of network. And if you work with network, you know that it is unreliable. Like, you think that service is working, but like network might have some issues, especially when you have high scale. So that becomes quite a big issue. It is not really secure. We cannot trust the network. I mean, you can trust it, but probably you shouldn't. So that is something to consider. And latency. So even though it's inside the cloud, maybe the same, but yeah, latency is always going to be higher than just joining two tables or having a function in the same code base. So yeah. It is more complex. It is a bit easier to work in one code base than having 5, 10, 40. Yeah, why do we do 40? Yeah, yeah. So it is more difficult, more complex. Yeah, you have a big risk not to get it right. So you say, okay, we have microservices, but we need to deploy all three at the same time, because otherwise this will break and that will not break, and so on. So that's what we would call it a distributed monolith. You just have more servers, more code bases, but the same issues. And granularity is actually quite tricky to get right. Yeah, micro. What does it mean, micro? No one knows. We know micro is not nano, it's not lambda, but what does it mean, micro? So yeah, very difficult to get granularity right. And very likely, if you don't want all the deployments at the same time, at the same second, and so on, you probably need to include versioning. And versioning is really easy to add, and it's very difficult to remove. So if you know to deprecate a version, it takes like 3 to 5 years, depending on who is actually using it. So, and that was the joke. I'm Spanish. Why would you work more? Why would you? I mean, it's like, as you know, we have siesta and so on. It's like extra work is not okay. So why would you do that? Yeah. One thing to consider is reliability. If you have two systems, they depend on each other. One goes down, the other one needs to maybe have a failover or also goes down and so on. So reliability is a concern. We probably need to have a failover when the system goes down. If you want your clients to use the system, if you don't mind, maybe it's okay. You also need to do some load testing to test when that happens. You need to have some observability. Some alerting, debugging, upgrading, security, sync with other systems, authentication, continuous integration. I think it's quite clear. And this is the new fashion in town, Monolith. So let's go why it's actually better than microservices. It is simple. And I really like to think as warehouses. Like if you actually had to do what we do, we buy clothes, we get them, we pack them, we send them, and so on. Would you start with 10? Probably you wouldn't. You would have only one. It's also faster if you had to move between one warehouse to another warehouse. You need an access key. You need to take a car. Probably it's windy and rainy here, and maybe the goods get wet, or someone steals it, or it's like it will take time. And if you don't have any network, you should have lower latency if you put the indexes in database correctly. So, yeah.
Yeah, thank you, Marco. And really good example about warehouses. As we have all here in the audience built multiple warehouses in our life, I'm sure we can super relate to that example, right? I'll give another example. So I'm sure pretty much everyone here in the audience has some sort of a wardrobe, right? Where you put your clothes, maybe you organize them by color, you put shoes in some place, then I don't know, pants in another place, and etc. But why is it so that you find socks somewhere in the room? Or why is it there a random pile of clothes somewhere on the table or on the sofa? Well, that is because we are humans and we operate this way. We opt out for the easiest path. We choose to do whatever is easiest for us. And same happens with the monolith. So in my book, monolith is almost equal as big ball of mud. You start nice. You say that I will create the best architecture. Everything will be tidy and nice. And after like a year or so, you end up with something that is not something that you envisioned. And why is it so? Because humans often opt out for the path of least resistance. If you can do cross-talking between multiple models or services inside the monolith, because it is easy, you will do so. And this is how we operate. And putting boundaries is very difficult around that. And if you also try to deconstruct your monolith, and you try to extract functionality, I'm sure you will find tons of functionality which nobody really knows anything about it. Maybe people who have put there, they're already left, they're already gone. Maybe the team doesn't exist anymore. It's just sitting there, and now you have to do something with that. So there's no clear ownership. Who put that? And maybe if this team put similar code in two places, or the code is connecting two things that shouldn't be really connected, now you have to untangle this mess. And another big disadvantage for it is that system evolution becomes a group responsibility. Somebody has to maintain the monolith. And from my experience, if something is a group responsibility, it's nobody's responsibility, right? You can agree to me, yeah? So you can do monolith correctly. You can try to put boundaries across modules and prevent them from cross-talking, but some of these ways can be perceived as hacks. It's not really nice. But at the same time, we have both good and bad examples of both monoliths and microservices. And now Marco will give some sort of an overview of how our services are laid out. So, please.
Yeah, talk for yourself about the socks, man. They are all in a pile where I know where to find them. So, yeah, but let's talk a little bit about examples. This was a little bit of theory, and let's talk about a little bit how we actually operate. Here we have a simple representation. As we discussed, we have 40 systems. You wouldn't understand, I put just few. So web shop, warehouse, brand portal is where we would actually put the product data, etc. Finance. Unfortunately, we need that. Yeah, Swedish doesn't like when we don't report correctly. So yeah, we have one more, 2 little microservices. I try to represent more or less the size based on the circles, but here we can see the web shop has 2.1 million lines of code. Yeah, that's scary. And then stock service has 15,000. So I guess we can call this micro and this monolith. So I will focus on web shop and parcel API, and later Edvardas will talk about the stock service. Let's say web shop talks to parcel API. Web shop is a big monolith. We have modules inside. Within those modules, we have teams that have the ownership. So the account, the checkout, the search, they are owned by different teams, but it's the same code base. It's the same code base, it's the same database. Yeah, it is pretty large. I guess you would call it monolith, even though it's not a single one for the whole company, obviously, but it still is big. We have divided the modules, owned by the teams. We use GitLab code owners, which is quite useful to make sure that everyone reviews each other's code, and we require that. And it is simple. We have one database. We have one CI pipeline, CI and CD pipeline. One slide too many. Okay, yeah, I thought it was in the same slide. Yeah, the drawbacks. So here you can see a little bit how the website looks like. One single system has scalability limitations. When you have multiple, you can scale a little bit more. A single one, it's a little bit more difficult to scale. Has many people working on it. I think there are about 40 developers with front-end and back-end working on the same code base, with the same CI pipeline, with the same database, and so on. We use a continuous deployment philosophy. So we have very few deployments, very few commits in one deployment, and very small ones. So we can probably deploy 30, 40 changes every day. That means that we need to wait for the whole deployment, the little canary deploy, and so on. So that slows down the deployments. We have shared ownership. Still, you try to have everything into modules, etc. There are common areas. Yeah. We have chapters, which is like all those developer front-end they meet, back-end they meet, 25 and 20. Try to have a discussion. It's not easy with 25 people, so that is actually a little bit challenging. And we have one database, so that's really hard to have ownership. You can own tables, but who owns the CPU of the database? Who is guilty when it goes down? No one knows why it went down. Who is gonna, not guilty, maybe not the word, but who is responsible? Yeah, so that would be the monolith. Let's go into an example of a microservice. Parcel API was actually the first one we separated from the web shop in 2017, I think it was. Itself, it just tells what pickup locations are available in that address for PostNord, for Instabox, or for whatever provider we have. In 2017, looked like a good idea. Was very small. We could extract it, have it separated, but what we noticed was too small. Like, when you don't actively develop it, when it's like every now and then you do a new distributor, it's not every day. Having such a small one requires a lot of maintenance. Also was mainly used by one service, so it was not independently scaling, it was next to each other. We also had to load test, so it became, and as there was one, yeah, more work, why would you work more? So, yeah. We decided to merge it back. and that's the most controversial thing. Someone is taking a microservice and putting it back to the monolith. I remember Andres looking at me like, why would you do that? We did. We already merged it back. And the issue is the granularity was too small for us. Like all the maintenance, all the work and so on, we didn't think was good for us. The team was not happy about upgrading, and it was lagging always behind. But our plan is like we merge it back to the main monolith, and later we'll extract a much larger service, which probably will have a lot more active development. We'll have probably 3 to 5 people focusing only on that one with a separate database, etc.
Yeah, but we also had some success stories with microservices in our platform. So one of those is Stock Service API. And there are some prerequisites that led to successful creation of this microservice. So first of all, it had a very clear and defined function. It had to answer a question, how many items of this product do I currently have in stock? And this is an important question, so you wouldn't oversell or undersell, and reporting correct numbers would hurt the business. And that responsibility was shared across multiple systems. And yeah, it was very difficult to actually tell how many items do we have currently in stock, because multiple systems would get different information from different sources. And consistency, maintaining the consistency was painful. So basically, to get things right, you would have to physically go to warehouse and pick a bin and say, calculate how many items you have of this. Which is, of course, I'm overphrasing. We didn't do that. I hope so, because it would be a long time to calculate everything. But as you understand, keeping the consistency across multiple sources of truth, it's difficult. And you cannot actually call source of truth if you have multiple of those, right? So how did it went? Well, it went good. So the good parts, first of all, it is a single source of truth. So we no longer have multiple different numbers for our stock. We have one which reports, and we trust the number that we have. The second good thing is that the team has ownership and autonomy, and this was very important, especially the autonomy part, because the technology stack that they could choose was very different from what we used in the platform back when. They decided to go with Elixir, which is based on Erlang, and this language gives a very good performance, consistency. It's a functional language, and using the current set that we had back when, it wouldn't probably work as well as it did with this new introduction of the new language. And it also was elastic and scalable. And I have a funny story that one time developers working on our web shop just switched off the cache, forgot to turn on the cache for stock service. And after a while, we noticed that, hey, there's something wrong with stock service. It performs very well, but the traffic has increased like multiple folds. What's wrong? And we didn't notice immediately. We noticed after some while. The stock service itself scaled to a certain number of instances, so we could keep the request still going and the traffic still going. So it has elasticity and scalability as integral part to it. And another thing is that it's rock solid and blazingly fast. And by blazingly fast, I mean sub-millisecond response times, minus network. And this is the important part, right? Yeah, and now let's go to the bad parts. So the challenges that we had to solve. So first of all, we introduced a new programming language. And if you're introducing something new, you still need some support from the rest of the platform. So we had to educate our developers. We had to find people that could be able to work on this new system, to interpret, to understand the code, what is happening there. And this language is now used more and more throughout our platform because we did a POC. It worked very well. So now we're expanding and we're adopting the implementation. network issues. And this is actually a big thing. Whenever you're designing microservice and you're not thinking about the network issues, possible network issues, you're doing something wrong. We experienced multiple things like split brain, where instances cannot talk to each other, and then they don't know who is the leader, whom should I trust. We had lost packets, we had some random latency increases, we had lost connectivity, name them all. So network issues is a really important thing. And then when designing microservice, you have to build in extra things in order to counter support these network issues. Let's say you have to think about replicating requests in case something happens, exponential backoff, a lot of stuff that needs to happen in order to support microservice. And yeah, I don't want to even talk about this thing. It's difficult, it's complicated. Yeah, and now it became a single point of failure. It's single source of truth, which is perfect, but it's also single point of failure. So if stock service is down, we don't really know how many items we have in stock, and it becomes difficult to sell them. You might undersell or oversell. So thus you need to also think a lot about reliability and implement some failovers and a lot of extra stuff just to make sure that the service is as available as possible, like 99.99% of the time. And you can read more about it actually in our tech blog. We have our tech blog. You see the QR code here. You can scan and go. And full journey and the reasons behind stock service and language choices and etc. So I encourage to read about it. And now we come to the conclusions. So what would we like you to bring from this talk and to remember from this talk? First of all is that assess the risk and benefits. There's no silver bullet architecture. If you're starting with microservices, it will mean bigger investment right from the start. And if you're a small organization, small company, it might even lead to loss of finances, bankruptcy, and all sorts of terrible things. So better not do that. But if you're too late in microservice to monolith conversion, you are then sorry, monolith to microservices. You know, that was incorrect.
But we've done that.
Yes, but it's not.
Okay.
It's, yeah. Okay, let's not talk about it either. So if you're starting too late, that means that probably it will be too expensive for you to split it into microservices. It will take a long time, and financially it might not even be a viable thing. Another thing is that usually scalability and performance are mixed as a single thing. It's really not the same thing. With microservices, you will probably get way more scalability because these services can scale independently. But since you're introducing network latency, you probably will not get better performance. You will handle more traffic, yes, but the traffic, like the response time will be not as great as something coming directly from the monolith. And a third thing is that hybrid approach is completely fine. If you have monoliths and microservices in your organization, it's completely fine. You don't have to switch to either sides. Even Solar module is fine, like we have. We have like a couple of bigger monoliths and supporting microservices around them. And yeah, find whatever works in your organization. Remember that microservices, they most help in the organizational ways, like to organize your teams, to make them more independent. And technological benefits, they come only as a second part. Yeah, and a couple more.
Yeah, and this is really important, regardless if you are actually having a monolith architecture or having microservices. The ownership is very, very important. Everyone's responsible. No one is going to do it. I'm Spanish, believe me. Nothing gets done over there. So regardless of what you choose, that's really, really important. And when you get to a team to a certain size, maybe 20, 30, 40, that's a question for you to answer. Doing microservices might help with those clear interfaces. And to bring back again that, the most important is the architecture will look like the organization. Regardless you want or you don't, if the teams work together, they will not talk to the other guys, they will do their own code and so on, regardless you have Monolith or not. So better separate everything as soon as you can, with modules, with microservices, etc. Especially if you have located teams in multiple places. In the same office is already difficult, in different countries. Yeah, there will not be a good communication. API documentation is easier to read than to talk to developers. And I think that would be it from us.
Thank you very much.
Thank you. You have more?
No,
more slides.
no, maybe someone has a question. Or
Yes, of course. While you're thinking about your awesome questions, I forgot to say, I left it here a lot of vouchers. It's a 25% discount for our website, so please take it. And yes, questions?
We already have 5G, and 6G is probably going to come in a few years. So the part about networks being a hindrance for microservices, what do you think about that?
Well, it's not about the client network, it's the microservice talking to each other. So it's like even though you have the same center, one microservice needs to talk to another one, it's not the same code base. So for example, with Elixir, we have very, very little overhead. But PHP, just loading up and getting the request and so on, will add you 20 milliseconds. Then the network, even in the same data center, I don't know, it's 8 milliseconds on top, something like that. If you need multiple internals to gather all the information to reply, you're still 100 milliseconds.
Yeah, zero latency doesn't exist in networks, and 100% SLOs also. And SLAs doesn't exist in network connectivity. That's something that is not even possible.
Yeah, and for a customer-facing application, you don't want to wait. Yeah, maybe the 5G is good and so on, but it's still like backend keeps going. Yeah, and it will take more resources also while you are waiting for that to reply and so on. So, yeah.
Oh, I sound really nice.
You should do a podcast.
Yeah, I know. Yeah, so you mentioned that you had the database for each microservice. Didn't that make a lot of data duplication, right?
It depends on the case.
Yeah.
It depends on the case. For example, in the stock service case, we actually don't duplicate any data. We use it as a source of truth.
Okay.
In other systems, we actually do duplicate the data because we don't want to make sure that system is up. We want to make sure they're independent, so we duplicate that data.
Yeah, and data storage is actually cheap. It's one of the cheaper things. Like you can duplicate it, and the way we view duplication, it's that every system can have their own representation of data. If you need it there, if you cannot wait for the network and you are fine with some inconsistency, you can have a representation of data inside this service or microservice. But the source of truth is still somewhere in an isolated microservice. So, yeah.
The second thing is, what about code duplication? Because if you're going to have one microservice that has one functionality, it means that if you want to have a different functionality but also connected to the same database, right? So you have code duplication everywhere, right?
And I have a controversial thing here.
Okay, yeah.
Dry is really bad pattern in some cases.
Okay.
So like don't repeat yourself. It's like don't be afraid of doing that. You can always agree with the owner of certain process and that streamline through it. And yeah, we have some code duplication. We are okay with it. As long as we test it and so on, it's fine. So yeah, we just try to put, okay, the owner of this process, like let's say an order, the order creation is in the checkout, we duplicate that and the warehouse will take that data going forward. Even though the warehouse might know better, but you need to agree who owns what and forward.
Okay, thank you.
So you've done too small and you have Monolith. What is the Goldilocks size? How do you know that, okay, this is just enough for one team, or do you have multiple microservices per team?
And here is where we have a mixed, I'll give you my opinion, and later I'll tell you some examples. For me, one team, one system is like golden rule. That's super nice. 5, 6 people have one system, they dedicate, they work, and so on. In some cases, we have one teams with 2 maybe.
Yeah. It's
3
possible.
At some cases, very rarely. Normally, it's one system, two max.
And remember, there's a maintenance involved.
Yes.
Every microservice needs to be maintained, right? And of course, you can build in the automation, but up to a certain level. Like, yeah. And
How do you handle the stable code then that nobody touches because it just works, but might need a little loving, like once every 5 years? Is that part of the monolith? You just keep it in the closet, or is
No,
that
we assess, for example, parcel API, that was the case. No one wanted to touch. It's not that the code wasn't good, it's just we need to upgrade security, like the PHP, for example, gets upgrades quite often. So we just saw that it was too much overhead, we merged it back. And about the closet code no one wants to touch, I guess that's based on the team. I don't think we have we don't have an answer.
no, the chance that this code that nobody wants to touch will lie somewhere in the monolith is much higher, because you can hide code in monolith, right? It can live somewhere between the modules, and
No, between those 2.1 million lines of code, there's as
there's no
tidy
place
as my
to hide,
code,
right?
as
Yeah.
my socks.
Yes.
That's,
yeah. So with microservice, since microservice has very defined ownership, when let's say team owns a microservice, then it's their responsibility to maintain it, and if the code needs some loving, they do that.
Yeah.
Thank you. Interesting talk. I'm thinking you tie organizational structure tightly to microservices or modules, I guess. But organizations also sometimes reorganize. How do you see that affect, or how that would affect a microservice architecture versus the monolith?
I actually have an example. One of the services we're extracting from the web shop is the product data. We had a cross-functional team with front-end, back-end, and so on. We decided, did it make sense? We have a full back-end team that will own that data, and they will move. So we actually structure the team based on the architecture. Sometimes we do it opposite. Most of the cases opposite, but in that case, okay, we structure the team based on the architecture we decided. Yeah, but things change, and people sometimes don't like those changes, but we try to keep it steady. We don't change things every day, but we see how it evolves.
Yeah. Somebody else? Okay.
You said that you had a monolith with 2.1 million lines of code. So I'm curious, the longest file, how many lines of code did you have in that one?
I don't know, and I don't want to know.
Yeah, I might know.
You know? Okay.
Yeah.
You wrote it?
Well, I touched that file as well. I put some code, and the funny thing is that this file, basically, we had to refactor one big feature, and it was really difficult to refactor. So we put new code on top, and we wrote a line that do not touch code below this line. Dragon lives below this line, and this was the way how we handled it back then. But of course, it's not the best way to do it. I'm not sure if it still exists. We need to check it.
I'm afraid to check, actually. No.
Huh?
How many lines was it? 10,000?
Tens of
60?
thousands, probably.
10,000.
Yeah.
Now that you have teams that does microservices and you have teams working in the monolith, what culture differences do you see between the teams, and do you see any difference in cycle time and so on?
Yes, cycle time is a little bit slower for the actual, but it's hard to tell because it was a microservice or microservice, because the web shop is also scarier. You are deploying something to a customer rather than internal system that is only used by some agents, or in the case of customer service. So the slowdown, our median is under 24 hours since someone starts coding till we deploy it. In other systems, it could be in 2 hours. They code it, someone approves, we automatically deploy. We don't have any process. So there is.
But it's a really good question, because I think one of the key things is a bit, well, it's not a bit, but it's proactivity. So teams that own microservices, they proactively maintain them, and they improve them. And if a team is owning, or 4 teams are owning one microservice, then, as Marco said, it gets difficult to organize this maintenance, and the proactivity part, it kind of also falls behind.
We can have a chat after also. Like,
Yeah.
Feel free to.
You said you deploy several times a day. Does this mean that you have a fully automated like deployment process, or is there any manual QA involved at all?
I cannot say fully automated because someone needs to click start. So I guess we just merge the code to the master. We click start and then it deploys. We have a canary deploy. Someone monitors. We have dashboards. We look at the errors, and then it goes to 100% of our customers within 20 minutes, 25.
So the person that watches the canary deploy is
A developer. Yeah. Not all developers can deploy to our customer-facing systems. The internal systems everyone can deploy. Actually, it's fully automated. You merge, and it goes.
Okay, my last question. Have you seen any difference then between incidents? Are there more frequent incidents in the Monolith than in the... Because if the teams now do love their own code, and the idea was that they do maintenance, do you see that in the numbers as well? Or do you follow up?
SLO1 is, we have high requirements for the web shop because customer-facing. So probably we actually have more incidents in the other systems, but because I don't think you can decouple it in that case. Also, the warehouse SLO requirements is lower. So
I would say the incident number in monoliths is a bit higher because you might break something that is not your code or that you were not aware because it's so big, right? And with microservices, to ensure the stability, even though if you're doing the deployment, if you're doing multiple changes throughout the day, we have incremental rollout, then there's other techniques to ensure that the stability is, and certain SLOs are met. But yeah, generally, to break bigger code base is way easier than to do it for microservice, in my book.
Especially in front-end.
We are back-end developers. We were back-end developers, yeah.
I am still. I wrote 2 lines of code yesterday.
Okay.
Okay, pizza arrived, so maybe some last question?
Or pizza?
Or pizza? Okay, pizza. Okay, thank you.
Thank you.